Hi everyone. In this lecture, I will explain the project overview and go over the application components that you will implement in this course. So, I will go to Excalidraw website and use it to draw the diagram of our project. First of all, this project will be a food ordering system. I will create 4 microservices that communicate through events using a message bus, which will be Kafka. Let's start with order service. Order service will be the first contact point for the clients. So it will have a REST API that can be called from a user interface or any REST client. So I will write down REST API inside order service here. In this course, I will use Postman tool to send REST requests to the order service. So here I'm going to draw the HTTP client, and it will be Postman. I will send HTTP POST requests to order service to create an order. The request body will be in JSON format. Here you see the example JSON request. When I implement the services, while calling the order service from Postman, I will use this input JSON data. As you see, I have customer ID, restaurant ID, address, price, and order items that has the product details. As a response, order service will return tracking ID and status of the order. An order will be created in the pending state. Later, clients will be able to query order service with HTTP GET endpoint and get the latest status. When the order starting to process, the order status will first change to paid and then it will be changed to approved. In case of a failure, the order status will be set as cancelled with the failure messages. If I return to order service, apart from REST API, I will need data access layer to communicate with local database. I will use Postgres relational database here. So I will add a database image and relate it with the order service. This is the local database. Also, I will have a messaging component that will allow to communicate with the message bus, which will be Kafka in this case. This messaging component will publish the events that will be created from the domain layer of order service. So the last but not least component will be the domain logic that will have the business logic of the order service. Let's draw the other services. First, the payment service. This service will complete the payment of an order. The communication will be purely based on events through Kafka. Again, in this service, I will have data access layer to communicate with local database. So I will put the database image also here. Then it will have the messaging components to communicate with Kafka. And finally, it will have the business logic for a payment operation. Next service will be the restaurant service. This service will approve an order by checking some business logic like availability of a product. It will again have the data access, messaging, and business logic. The last service is the customer service. At the start of the course, I will use a materialized view in the customer database that will be populated with a trigger on customer table. And I will let the order service to query the customer data directly from the customer schema. This will be possible as I will use the same database instance, although the schemas will be different for each microservice, following the database per service microservices pattern. However, later in the course, I will switch this structure with event sourcing and CQRS using Kafka and move the customer data to a table in the order database. Then order service will read the data from that table. So for now, I will draw the customer service here with a local database and relate it with the order service, adding a provides customer data arrow. Alright, here in the middle, we have a large space left. As you can imagine, Kafka will fill this space. So I will draw Kafka component here. The services will produce and consume events to communicate each other. And they will use Kafka to send and receive these events. First of all, to complete an order process, the first communication must be between order service and payment service. So I will create two Kafka topics, payment request topic and payment response topic. Order service will first create the order in the local database. So I will set number 1 on the order service local database to indicate that it is the first step. Then it will send the order created event to the payment request topic. So this will be the second step. Then payment service will listen this topic. So this will be the third step. And then it will process payment in the payment database, which will be the fourth step in the order processing. Then it will create a payment completed event on the payment response topic. And this is step 5. Finally, order service will consume the payment response topic and update order status as paid in the order service's local database. So the message listener will be step 6, and the database update on the order service will be step 7. As you see, the order service local database is updated twice up to now, in step 1 and step 7. Then, to get an approval from restaurant, we will need another two Kafka topics. Restaurant approval request and restaurant approval response. Order service will request an approval by creating an order paid event on the restaurant approval request topic. This is step 8. Then restaurant service will consume this topic with step 9 and process approval of order in the restaurant database. This will be step 10. And then it will create a restaurant approved event on the restaurant approval response topic, which will be step 11. Finally, order service will consume the restaurant approval response Kafka topic and finalize the order by setting the status as approved on the order service's local database. So I will put step 12 in the message listener and then put step 13 on the local database of order service. Here you see the high-level overview of the data flow of an order process. This picture and steps actually the baseline for Saga pattern implementation. Here one thing to notice is that the order service acts as a coordinator for the Saga flow because it initiates the Saga, then gets payments completed event, and then asks for approval to the restaurant service. And it finally completes the order with approved state. At that point, it will return the approved state to the client when it is queried using the GET endpoint. And after that, the client can trigger the next steps such as the delivery process. So I will follow this flow and additionally add Saga step interface with process and rollback methods that will be implemented by each step. Each Saga step will require two methods, process and rollback. Because in case of failure at any point, previous operations need to be compensated in Saga pattern. So this will be achieved using the rollback method in each Saga step. And later, when we implement the outbox pattern together with Saga, we will also track the Saga status and outbox status next to order status. Alright, current picture has almost all the components that you will implement in this course, but this picture is far from complete. To complete it, we need a clear architecture with a well-defined domain logic, and also we need to cover failure scenarios for Saga and CQRS patterns. So let's start improving this architecture. I will do that in the next lecture.